Wow, 5 failures in a row. A few days ago, I posted a video where I built a PVC rocket motor and showed you my struggle with sugar fuel. Sugar fuel is honestly disgusting. That video turned out to be a failure because I didn't cast any fuel grains. But in today's video, I'm going to show you how I made a new type of fuel for the rocket, the full build of my PVC motor, and why I had to travel far away from my city in order to continue working on rocket fuel. It's going to be a little bit like a vlog, and at the end of the video, you'll see why my new rocket fuel actually worked against me. All of that is coming up ahead. And just a quick note, this is not a tutorial video. Don't try to replicate anything you see here at home. First, I measured all the ingredients on a kitchen scale before mixing them together. I'm going to use charcoal as the fuel and dextrin as the binder. Charcoal's easy to get since it's just burnt wood, and dextrin is also available online. But instead of buying it, I made my own by cooking cornstarch on low heat until it turned golden brown. And just to clear things up, this white powder you see is not potassium nitrate. Try to guess what that powder is in the comments. If you've watched my earlier rocket motor building videos, you should already know what it is. After measuring, I carefully mixed all the ingredients together to make the fuel. The dextrin I added is very important because I'm going to use water to cast the fuel. Dextrin acts like a glue when mixed with water, helping the fuel hold together. If you want to see exactly how I made dextrin, just comment dextrin below and I'll make a video on it. I also gave the mix a good shake to make sure everything blended well. As you can see in the test of this fuel, it burns a little too fast. So later, I added some more dextrin to slow it down a bit. After making the fuel, I jumped straight into forming a cool-looking grain. To make it castable, I started adding water to the fuel. Not too much, just a few drops at a time. Thanks to the dextrin, the fuel began to get a clay-like texture, and once I was able to form a ball of fuel, that meant it was ready for casting. For the mold, I took a piece of PVC pipe and added a layer of thick chart paper so the grain could be demolded easily. This method is much easier than making rocket candy grains because it doesn't involve heat. It gives me plenty of time to cast the grain, and it's safer than casting sugar fuel. Bit by bit, I packed the clay-like fuel into the PVC using my fingers. After that, I made the core using 2 washers, the same ones I used in the motor's nozzle, and a lipstick tube that fit perfectly inside the washers. The results were very good. The grain looked clean, though one side was a little messy, but that can be trimmed later. Honestly, this is the best fuel grain I've ever made. I admired it for a while and then left it to dry. Drying can take up to 3 days for this type of fuel grain. So, while it's drying, let me give you a quick setup tour. Here's the grain drying, and just behind it is that huge tree I planted 7 years ago. There isn't much sunlight here, which is good, because direct sunlight can crack the grain. This is also where I record all of my videos. It's looking a little messy right now. That pipe you see might look weird, but it's actually really important because I mount my phone on it for top view shots. Let me just show you. And here's the rocket motor I showed you in the last video. Also, I have a very important question for you guys. I found this thin wire inside an old soldering iron. I want to know, what is this wire? If any of you know, please tell me in the comments section. The grain was drying and everything seemed fine. I thought I'd test it once it fully dried and then move on to making the motor. It was about 90% dry, so I placed it in the open air on the roof. But when I came back to check, I couldn't find it anywhere. I searched all around and asked everyone, but nobody knew anything about it. Later, I discovered that somebody had thrown it off the roof, and I never found it again. It was really disappointing, but at that point, trying to figure out who did it would have been a waste of time. So, that very night, I started making a new grain. Sorry for the video quality here. It was filmed at night. I tested the fuel, cast the grain, and left it to dry. By the evening of the next day, the grain looked dry, but it had some cracks because I left it in direct sunlight. I wrapped it in aluminum foil and black tape, then set it on fire. At first it gave off some flames, but then it only produced smoke. After the burn, some black residue was left on the test site. The fuel didn't perform the way I expected. After thinking for a while and testing some leftover fuel, I realized the problem. The grain wasn't fully dried. The drying time should have been at least 48 hours, but I had only let it sit for about 24. The same black residue also appeared in a test I did with the wet fuel. Now I knew exactly what to fix. Using that knowledge, I started making test grain number 3. For this version, I added one more ingredient to the recipe to make it burn a little slower: cement powder. Cement powder acts like a binder and helps make the fuel less sensitive. I also reduced the oxidizer, increased the charcoal, and added a little extra dextrin along with the cement powder. Once again, I tested the fuel, cast the grain, wrapped it in foil and tape, and this time I let it fully dry. When tested, grain number 3 performed very well. It was powerful and reacted quickly, maybe a little too quickly. After that success, I decided to build 3 grains for the main motor. But once again, another problem was waiting for me. Just as I started recording the build for the main rocket, I realized the white powder I had wasn't enough. And that's where the race began. I didn't know what was going on, but nobody was selling that oxidizer in my local area. I tried really hard to find it, and even my friends were searching for me, but they couldn't get any either. So the next day I decided to travel to a village where I was 100% sure I could buy it. I could have ordered it online, but the price there is just too expensive. I called 2 of my friends, grabbed a bike, and we started our journey to that location. This trip was totally unexpected, and that's the main reason why this video is a bit late. But honestly, the trip itself was fun. After riding on the highway for a while, we entered some narrow roads surrounded by rice fields. Sadly, I couldn't show much of it to you because of the low quality of my phone.
Recording hari schema either. Kita aja apa? Anjir era IP. Label video
After about an hour, we finally reached the village. It was far away from the city and very peaceful. My relatives live there and they helped me find and buy the oxidizer. I wasn't able to record that part, but it was a quick deal. After that, we headed back toward our hometown. We had a lot of fun on the way back, as you can see from these video clips. At one point, we even came across a guava tree in the middle of the rice fields.
साले करड़ा तोड़ लिया मैंने वाह किसी सूत्रा लगा
The guavas were really sweet, so we picked a few kilograms and continued our journey home.
चल
किसमें खाते हो पाँच
The trip was great, and as soon as I got home, I made a fresh 150-gram batch of fuel and started casting grains. The recipe was the same as the test grain, but with more dextrin and cement powder and less oxidizer. I used a frying pan to prepare the fuel and made a chunk of wet mix. I covered it with a cloth so it wouldn't dry too fast and become crumbly. The whole process of casting 3 grains took over an hour. The tools I used were the same as you saw earlier in the video. I don't even know if I should call them tools, but they did the job just fine. By the end, I had exactly enough fuel to make 3 grains. Not too much, not too little. The grains looked so beautiful that even the rocket motor couldn't handle their beauty. And you'll see what I mean later in this video. But once again, it was time for waiting. And honestly, I hate waiting. Nobody in this world wants to wait, but at the same time, nothing worth achieving happens overnight. I think waiting is actually the way to win. With that thought in mind, I waited another 2 days until the grains were fully dry. Now the grains were fully dry, and technically, our rocket motor could be assembled. But I want to mention something. One of the grains had a long crack running from start to end. I didn't dry the grains in sunlight, so why it cracked is still a mystery. Anyway, I decided to place that cracked grain at the bottom. I started gluing and taping the grains together. I had seen this in a YouTube video, where they used glue to stick grains into a single long rod of fuel. So I tried the same. After wrapping them in thick chart paper, they were ready to be inserted into the motor body. I trimmed the extra paper and made cuts at both ends of the motor body so the nozzle and end cap could fit tightly. Before assembling the motor, I also added a thin layer of glue to both ends of the fuel grains. Not that it made a huge difference, but it was just for extra safety. I let it dry for a while, and once it was ready, I began assembling the motor using PVC cement. Since the nozzle didn't have much surface area to bond with the body, I drilled a few holes for screws to hold it in place. And with that, my first ever high-power rocket motor was ready to be tested. The next day, early in the morning, I packed everything into a school bag, and a few of my friends joined me for the test. Sorry, I forgot to record the preparation part, but this was honestly a pretty pro-level setup. As you can see, we used a metal bottle as a stand for the motor and tied 2 ropes to hold it in place. My original plan was to measure the thrust using a weight scale, but since there was no way to properly record the numbers, I dropped that idea. Instead, we set up our phones to record, placed the igniter inside the motor, and let it go. Wow! 5 failures in a row. But honestly, I didn't expect this one to fail. The motor was well made and the nozzle was large enough. Still, as you can see in the clip, the motor got overpressurized the moment the igniter lit up. I'm pretty sure the fuel I used was burning way too fast. And of course, we can't ignore the fact that one of the grains had a big crack in it. So from this test, it's clear. I still need to experiment with a more stable fuel type and avoid using PVC as a motor body. In a future video, I'll try to make a full metal rocket motor with a much safer and more stable fuel mix. That's going to take more time, but it will definitely be worth it. If any of you want to share your ideas with me, you can check the description for my Instagram and my Discord server link. Thanks for your time, and I'll see you in the next video.